Our esteemed internal session chair for ICACTEA 2026 is Dr. V. Ravikishore sir, currently serving as an associate professor in the Department of Computer Science and Engineering at Aditya University. With more than 17 years of teaching and research experience, he holds a PhD in Computer Science and Engineering and is currently pursuing a postdoctoral fellowship from the Singapore Institute of Technology, Singapore. He holds a PhD in Computer Science and Engineering. Dr. Aditya sir has made remarkable contributions to research with over 40 research publications, including SCI, Scopus, IEEE, and Springer indexed papers, along with several book chapters and patents. Dr. Aditya sir has received the Best AI Award at AI Fusion Summit 2025 for his work on threat detection using explainable AI. He has served as a resource person, research supervisor, editorial board member, and conference coordinator, inspiring both faculty and students through his expertise and dedication. It is truly an honor to have such an accomplished personality among us today. Let us extend a warm and hearty welcome to Dr. V. Ravikishore sir.
Before we begin the paper presentation session, I would like to briefly explain the presentation pattern for today. Each participant will be called based on their paper ID, paper title, and author name. After being invited, the presenter will proceed with their presentation. Once the presentation is completed, our respected evaluators will provide their valuable comments, suggestions, and queries for the further discussion. Now, I would like to invite paper ID 168 titled Transcale, Transformer-Based Model Scaling Framework for Multimodal MRI Brainstorm Detection by Pramila Rani ma'am.
A very good afternoon to everyone, and I warmly greetings to all the session chair members. And here I'm going to introduce myself. Myself is Pramila Rani, and I'm currently pursuing my PhD in Central University of Pondicherry in the research domain of medical image processing. So in my today's context, I'm going to explain about my research work on Transcale. It is a model which is using for transformer-based model scaling framework in multimodal MRI. So we know that multimodal MRI images means if you are having any brain clots, means here I'm going to work on the session called as brain stroke. What do you mean by brain stroke? Means when there is a flow of blood is interrupted in our brain, it will cause two different types of things. One is called as hemorrhage and second one is called as a stroke. Okay, means the person is going to be done a paralysis mode or maybe in the coma state. That will be explained as a brain stroke here. Okay, how I'm going to detect or identify that brain stroke by using my multimodal features here. Okay, that is going to be explained in this paper. So coming to my session, I'm going to introduce the introduction, followed by the literature review, followed by my methodology and results, and finally I'm going to conclude my paper. So this is the introduction. Nearly 13 million people are affecting with this brain stroke. Even in from childs to the old age people are mostly affecting with this brain strokes nowadays. So what is the main reason? Means there will be two different losses. One will be the blood flow that will be clotting in our brain that leads to the hemorrhage, and second condition is our blood vessels will be broken. That is the second condition. That has to be detected as early as possible. That is going to be using with MRI sequence scans. Next one is, here I am going to introduce the transformer or Transcale for detecting this brain stroke in the human body. So these are the different literatures I have followed for the different papers published in Elsevier and Springer and Science Direct. So all these papers will explain in mainly on CNN based with multi-features. So I want to improve these model detection using a transcale, which is advanced to the CNN models. Why CNN model is least performance for this brain stroke, I want to explain this thing. So we know that all the convolution neural networks are very good at accuracy. Even on smaller data sets, they will predict the good accuracy scores. That we are all aware of. Next thing is, these brain stroke images, what we are calling that magnetic resonance images, MRI. So these are having only, when you use the CNN model, only small spatial features only detected, no, not the longer range one. Okay, so that is the main limitation of these CNN models, that what I want to improve in my transformer scale. So in my methodology, I want to develop a different multimodal long spatial features. Here long spatial features means when a brain stroke is attacked, we have to diagnose with that the thing is basing on their shape, size, texture, because blood flowing from one area to another area will clot some part of our body. That forms to lesions. Lesions means clotting of the blood. That flowing in causing interruption to the vessels. That part we have to identify. That will be identified by with the different features, okay, by basing on their size or shape or texture or more than that, structure of that vessels, okay. So coming to my model, I want to investigate on different modalities, means model quality I want to increase on different features, like first feature is DWI, diffusion weighted imaging, where the blood is clotted in that particular vessel. First I have to detect that lesion part. That will be done by my first feature called as the DWI method. In coming to the second method, ADC, apparent diffusion coefficient. Here I am going to track what is the body part that is affected with that lesion. And coming to the 3 and 4, flare means fluid attenuated. We know that blood is a fluid level. So we have to find that where are the major injuries have been occurred by the process when the blood is flowing from there. Because when the blood vessel is cut out, we can't able to cure that thing, ultimately leading to the loss of the brain dead. So we have to identify that part. That is be calculated with the help of the flare and T2 weighted. Both these are helping various blood vessels that are clotted due to this thing. Okay. So basing on these 4 MRI modalities, this is called what I am going to call as multimodal. Because in previous literature survey, any of the researcher have done either 2 or 1. Not more than 3. So I want to use more features. So that's why I came for this, all the 4 different features in single model. This is my architecture of the model. First, I am going to take the different MRI scans in different proportionates in the longer range and the smaller range of the scans. So that is going to be given to first phase called as multimodal MRI input. Here my input is MRI scannings only. Those scannings will be taken from the nearest medical centers. I have collected nearly 4,862 samples of MRI different scans with different resolutions. After that, giving as input, I will apply the pre-processing of my data. Means normalizing, rescaling, flipping, cropping, rotation, means I want to detect in different aspect of the same image in different conditions. So I will pre-process my data. Later I will divide that into tokens, different tokens. That what I am going to call as my second step, that is called as sequence specific tokenization. In the previous slide we have seen that 4 different features I want to study. That is called as DWI, diffusion weighted imaging, ADC and flare and T2. That basing on the image, that tokenization is going to be segregated, segmentation. In simple words, I am going to do the image segmentation basing on these 4 different features. After that, I will do the third step called as multi-sequence transformer encoding. Here means I am going to do encoding in self-attention mechanism. Here we have to know what do you mean by self-attention mechanism. Every feature has to learn itself what is happening in that image. That is clearly observable. Each and every small scan or in the longer range also. If you take your photograph in the longer range, you will get some blur image, right? So that blurry image also has to be scanned properly. With the help of this encoding technique, I will convert the blur image into also a neat portrait for detecting that lesion. After that, I am going to my novelty, that is a fourth step, compound scaling. Here you can see that different layers. Alpha stands for the depth, beta stands for width, gamma stands for heads. Okay, here when we take the images like this, it is forming some main important layer. Means after all this process has been done, one final image will be done. That is what we are going to call as compound scaling. These all the depth. If you take one image, it calculates the depth of the image. What is the width of that image? How many heads? Means if you take the MRI scans, how many number of heads, or if you take one single head, what is the plot of that thing? Because brain, if you take MRI scan, 4 different image slots will be available for us. So it will read all those layers and give the final depth and width and head count with integration. Means I am here using the flops count, flip-flops count. So this is nothing but what I am going to call as self-attention mechanism of my model. So these are the things I am going to do in my methodology. After that, so you can observe these are the 4 different processes that I followed. First one with the tokenization, next multi-sequence transforming and integration. Whatever I explained in this diagram, those are going to be my different steps here. After that, I am doing the compound model scaling. Later, if I compare all the CNN models with my transformer scale model, these are the outputs I have got. In the point of accuracy, sensitivity and specificity, I got the more result when compared to the regular CNN models. If you take the CNN models, when I do the iterations or the epochs, what I observe is on even the smaller data set, the CNN are training very well. And with the smaller features only, they are giving the good results. If I give the larger data set and with some blur images, they are not doing giving best accuracy or in the point of specificity and sensitivity. That's why I have chosen this transcale method. So these are the pictorial representation of my parameters on transcale tiny, small, base and large. Means depending on your data set size and again classification of your MRI images, we are able to use these different models. And coming to my results, without cross sequence attention and without hierarchical model, how the values have been trained for that transcale, and with using that one, what is the accuracy and flops values, you can see that thing. So these are the performance levels of my computational cost on different CNN models with my transcale model comparison. Later, this is the attention method where I have given my image scan and it is have been used different cross sequencing methods. So the image is going to be usually seen like this. So finally my conclusions are nothing but if we use only smaller data set with less number of images will not give the interpretable clinical validation. Nowadays we are generating so many methods, but all the methods are not truly clinical relevant. Means without a doctor diagnosis, we are not able to judge that is a brain hemorrhage or a brain stroke. So by using these transcale methods, we can invent a clinical intervention. That is my conclusion of this method. So in point of accuracy, it has given from 93.8 to 96 depending on tiny, small, large scale transformers. So my future work is going to be done on what are the different brain stroke subtypes, classification, and what is a lesion segmentation. Means if you found any brain hemorrhage or any interruption. So what is the segmentation of that image that can be studied, and with medical intervention I want to produce much more better awareness on this brain stroke. This is my paper presentation about this, my topic. Thank you.
Yeah, so good presentation. What are the other parameters other than accuracy that you have used for your work?
Sensitivity and specificity, sir.
Only that much.
Actually, here we are using so many parameters, AUC, F1 score, depending on different parameters here,
How
sir.
do you differentiate among them?
So here sensitivity and specificity, where we are going to take the false positives and false negatives for the blur images, sir. So if we take the image in a longer spatial things, we are not able to exactly convert that shape and size of that lesion, sir. Injury that is happening in internal. When a blood vessel is cutted out, the internal injury we can't able to detect. So for that, there may be a possibilities of false positives and false negative will come under in regular CNN models, sir.
Right. In the first model, ResNet 3D 101.
Yes, sir.
Your flops is 192.
192, sir.
Yeah, so what you want to say with this when you compare with others?
Because if the flops are increasing, sir, the time computation speed is increasing, sir. Means the iterations and the computation is taking much more longer time. While doing this experiment, it taken.
Comparing with accuracy and flops there.
Yes, sir. When I'm doing my execution speed with the accuracy with the flops, sir, it takes in more time, sir. Means it taking the data and analyzing the data, normalization and pre-processing, it takes more time. That's why it is needed more flops, sir. And after taking so much time, it is giving that 91% of accuracy. Nearly it is taking off nearly 8 to 10 hours for that model, only for ResNet, when I trained, sir. So if the flops are increasing, the accuracy also increasing. That is a good point. But comparing to the clinical intervention, if time is very precious in their point of time, sir. So when a doctor want to identify this much of time is more precious, that is a default that is I have seen in ResNet, sir. CNN model.
Okay, what about the cross-validation that you have taken?
Yeah, I'm using cross-validation method as a leave-out specific method, sir. Leave-out method. Because if I take all the images at once a time, sir, I am leaving out wherever the main longer range hemorrhage is happening, sir, that will be trained first, sir. According to that, I will do my cross-validation techniques, sir. Out of all methods, cross-validation methods, leave-out method giving the best results, sir, from my method.
Okay, very good.
Thank you.
Thank you, ma'am. From now, every participant will be having 8 minutes of time limit, and then they will be having a bell sound. Within that, they have to complete their presentation. Thank you. Now, I would like to invite paper ID 188 with paper title Dual Base Transverse Electric Mode Antenna with Enhanced Characteristics.
Good afternoon, respected panel members and my dear students. So I am Dr. Ravi Sharath Kumar from KKR and KSR Institute of Technology and Sciences, Guntur. I completed my PhD from Mizoram Central University, and when I started my research work, I started working in the antenna design. So first of all, I want to introduce my project. So you may be doubtful that why in the computer science I am going to explain antenna design. The first thing is the application. So my antenna, which I designed, 2 or 3 antennas I designed in my PhD work, that is applicable for underground applications. And secondly, the design aspects may include some algorithms. So that is what I am going to continue in my work. So initially, I will explain the principle working of the antennas. It will be a little bit of Maxwell's principles and how the E field and H field will be coming, what is the novelty of my structure, and finally, I will be concluding why I am presenting this here. So if you observe the title, it is a transverse electric electric based dual band antenna. Actually antenna consists of three important parts, that is ground plane, substrate and patch. So generally if you are considering the normal antennas, ground plane will be copper and substrate will be of any type material and patch will be of copper. And if patch and ground plane are the copper, then you will be getting a transverse magnetic wave. So what I did in my work is, like, I made a transverse electric mode excited antenna. So for making the transverse electric mode excited antenna, we can go with the magnetic ground and magnetic patch. So basically, like perfect electric conductors, we will not have the perfect magnetic conductors. So for making the perfect magnetic conductors, I made an artificial magnetic conductor which I designed initially. So in my work, whatever the artificial magnetic conductor I designed, that is also a novel design which gives the dual periodicity. So, and especially whenever I am working in these antennas, it is like a low frequency antennas below 1 gigahertz. Why I selected this frequency is, the research, means the literature shows that below 1 gigahertz it is suitable for the underground applications like mining applications, underground agriculture applications, or whatever the means underground things. So that is why I selected the frequency below 1 gigahertz. So in the antenna theory, it is like whenever the length is inversely proportional to the frequency. So whenever I am going with the low frequencies, size will be larger. So first thing is how to miniaturize the antenna and how I am utilizing the artificial magnetic conductor for miniaturization as well as for getting the dual band. So if you observe the antenna structure, so the antenna structure consists of three parts, that is the bottom one, that is the ground plane, and the top one it is the patch, and in between there will be a substrate. This will be the substrate and it is well probe fed, and if you are observing the patch and ground plane itself is a three-dimensional structure. So patch is a 5x5 array and patch is a 3x3 array and ground plane is a 5x5 array. So because of this artificial magnetic conductor patch and the ground plane, the cavity excited here is a transverse electric mode cavity. So if you observe how the antenna is built, so initially the artificial magnetic conductor consists of three layers, that is copper and dielectric. So I selected the dielectric as 10.2 and metallic strips. So whenever I am embedding ABC, I am getting the D. Right? So this is a AMC unit cell where we are getting a strips. So in the back side we will be having the copper. A plus B plus C is equal to D in the diagram. So now what is the novelty in my antenna is, so whenever I am taking this AMC unit cell, so this is the resonance where the AMC unit cell is working. So you can observe that it is nearly 850, and whenever I am keeping this in the antenna ground or antenna patch, I am placing in such a way that there are two gaps, which is termed as a periodicity in terms of antennas. So there are two periodicities, and D shows the dual periodic nature of my array. So whenever I am placing such an array in ground plane and antenna, I will be getting dual periodic antenna. So this is how I am getting the dual periodic nature in the PE antenna. So whenever we are going with transverse electric, so here you can see the magnetic field distribution. So generally the concept says that whenever we want to get two bands, we require two physical lengths. So in my antenna, there is only one patch that will be operating in the two different virtual lengths. So this will be showing how the two lengths are coming for my single patch. So at 541 and 713, the magnetic field distributions are shown. Why I am showing the magnetic field distribution is because I am going with transverse electric. Suppose if I am coming with normal antennas, which is a transverse magnetic, I will be showing the electric field, but here I am showing the magnetic field. So the graph shows the S11, which concludes the two operating bands and the gains of the two operating bands, which is operating at 541 and 714 megahertz. But the thing is, this is the design aspect, but now I want to finally conclude the presentation. So you may be like thinking why I am telling this antenna design here and why I want to present in this conference. First thing, as I told in the beginning, it is because of the application. It is an underground application. And secondly and most importantly, if you observe my antenna structure, clearly there is a pattern, there is a repetition, and because of that repetition, we got the periodic nature, dual periodic nature. So I am thinking to extend this work by implementing an algorithm I'm continuing this work, and now presently I'm working with a quad band antenna. So I designed a quad band antenna and it is under fabrication. So this is my work, and I want to design any one of the algorithm like to optimize the structure and optimize the things in this antenna. Thank you.
Good presentation. I just want to know what kind of optimization that you want to plan.
So optimization in the sense, how many bands we can get, more number of bands, because versatile soil conditions require different frequencies to be operated. So that is why we want more number of bands.
Right.
So here I have implemented dual periodic nature.
Right. In the optimization also, what kind of algorithms you just thought?
That is what I want to take the work forward, sir. Actually I am from ECE background, so I am less aware of the algorithms. I want to take this to the implementation of the algorithm side.
Right. Application domain, I just want to know, since you said it's from underground.
Underground, sir.
So will it be applicable to underground mining?
Mining, yes, sir. Underground mining, it is applicable to find what is the type of material available underground.
This antenna, how far it can work, like in the mining, underground mines? Do you know the depth of the?
Yes, sir. We tested, whenever I was doing my PhD, I tested, sir. I dig some holes with some like 3 or 4 meters. And we kept one antenna in one place, and we took the signal strength and all.
I just want to know that we need mining underground mines. How deep it goes, that you just have a thought actually.
So primarily we were thinking that depending on the reflection, antenna signal reflection, we will be finding whether the material is present or not.
Okay.
And then we must extend that to like, how much depth we can go like that. In the meantime, I finished my work and I came to my college, sir.
Okay, college job. Fine. So any other questions that you?
Yes, sir. Yes, sir. So range of the band is like it can be less than 1 gigahertz is suitable for underground frequencies or underground propagation. So actually in my slide, I think in one of the slides 431 I might have highlighted, that is the mica mode family, which is a wireless underground sensor network, sensor node.
So is it suitable for underground?
Underground IoT means the purpose is like WIoT is coming into picture.
Yeah, because some research going on like 6G.
Yes, sir.
So beyond that.
Beyond that. Means that is going in a higher frequency and going in the opposite directions.
Okay. So
I'm going with low frequencies.
Sir, how we are going to work on the problem of radiation, sir, antenna radiation?
So antenna radiation depends upon like how we design, sir. Actually we'll go in with the factor called the specific absorption rate. So if the SCR is in the acceptable range only, then we will release the antenna. Suppose for if we are going with the wearable antennas, SCR will be tested. After that only we will be releasing into the society.
What about the polarization, sir?
Polarization.
Antenna polarization. So what type of that thing it would be?
So
Of your type.
means it will be parallelly polarized, sir. And that depends upon the antenna orientation. Suppose if you are going for this underground application, suppose if you are keeping like this, it will be with the parallel polarization. And suppose if you are keeping like this, it will be perpendicular. So that depends on the applications. Thank you.
Thank you, sir, for your insightful presentation. Now, I would like to invite paper ID 187, text title, Texture Gradient Fusion.
good afternoon, dignitaries, and good afternoon, dear students. Myself, Narayanam Sri Prakash, and I am currently pursuing my PhD from Mizoram University. Today, I am going to present my work. The title is Texture Gradient Fusion Transformer Network Based Pothole Detection System on Roads for Autonomous Vehicles. So, first of all, I just want to know, convey that why I am keeping the title of an autonomous vehicle. So till now, we are having 6 levels of autonomous vehicles presented in entire universe, from level 0 to level 0 to level 5. If you are considering level 0, so this level 0 vehicle belongs to the non-autonomous vehicles. We can considering as a small vehicles, basic model vehicles. But if you are considering level 5 vehicles, those are belongs to the fully autonomous vehicles, which is under trials. Coming to the Indian scenario, in India we are having level 2 vehicles are already running in the India. So my work is focused on level 3 vehicles. So in that level 3 vehicles, actually nowadays the problem is the vehicles are used more and accident rate is also increased. So according to the World Health Organization reports, annually nearly 20 to 50 million accidents are occurred. In that 1.19 people are died. So to decrease that particular accident rate or death rate, most of the countries are preferring autonomous vehicles nowadays. So, but there we have a problem that we have National Highway Transport, Traffic Safety Administration. So in that NHSTA report, there 400 autonomous vehicles hit the accidents in the year of 2022. And in the October 2023, one autonomous vehicle hit the pedestrians in foreign country. So these are the, in foreign countries, that vehicle is belongs to, in 2023 accident vehicle is belongs to the level 4, which is under trials vehicle. So with that reason, I started working on this particular domain. So in this domain, what I found is we need to focus on pothole detections also. If we are having, when the vehicle is running on roads, there some potholes are there on the roads. So with that reason, we need to clarify whether the pothole is presented on the road or not. So for that, some of the papers are already existed in that pothole detection, but the problem with that is there we are having less accuracy when compared with problems. So for that reason, I started working. So I proposed an algorithm called as a texture gradient fusion transformer network. So in that network, I collected a data sets of both normal images as well as the pothole images. So later I pre-processing that images, and later it will be converted into feature extraction as well as the TGFT net algorithm where I am working. And later it will go to with the prediction stage. In the prediction stage, I provided some inputs as an image, which consists of potholes as well as the normal images, and it will predicted whether the image is having the pothole or not. In the pre-processing stage, I provided the inputs both normal as well as the potholes. In the pre-processing stage, it will be resized with a fixed resolution of 224 by 224 size to reduce the complexity and improves the processing speed, and it will be represented with the equation of I of x comma y. And later, resized images are applied to the normalization technique to improve the numerical stability from 0 to 255 to 0 to 1 value to the numerical stability, and it will be represented as a n of x comma y. And the augmented technique, that what I provided is I am going to do the operations like rotation of the images, flipping of the images, scaling and zooming of the images to retain the values perfectly. Because why? Because some of the potholes may be detected or may not be detected due to different image scaling patterns. So with that reason, I scaled with different proformas. And the texture gradient, the proposed algorithm is a hybrid deep learning model which combines the mid-level texture gradient information with the low-level texture characteristics, which can improve the future discrimination to detect the imperfections presented on the particular images which are provided by the potholes. And later the TGFT net is work with CNN and to perform the pre-processed images, and later I applied for the gradient technique to detect the sudden changes applied on the pixel values. And the fusion transformer network encoder is also operated to detect whether the space is getting or not in the linear mapping. And in parallel, localization head is also protected to provide the bounding boxes coordinated on the potholes. And these are the results till now I received for this particular algorithm. I received an accuracy of 99.25% whether the pothole is presented or not. And these are the graphs that what I provided for approaches versus accuracy as well as the loss versus accuracy. And these are the images I provided for the input. So I got an accuracy. This is the normal image, and these are the pothole images. These are represented as an output. And when compared with the existing algorithm, yellow V8 algorithm, I got 19.25%, whereas yellow V8 is getting 97.34% algorithm. And this is the graph for comparison I provided. And coming to the conclusion point of view, my algorithm, that what I proposed, received an accuracy of 99.25%, but I think it's not the good accuracy whether detecting potholes or not, but I'm going to further work on this to get the at least more than this percentage. Thank you.
This accuracy, whatever you are mentioning, 99.25. So what about the standard data sets that you verified?
Actually, I collected the data sets from the roads as a video, and it will be converted into the images. If time provides, I will show the data
It's
sets.
okay, it's okay. And coming to the, you are just working on only path holes or any other work related to autonomy?
More work is going on. First objective, because I split it into the objectives. In the first objective, I worked on road classification, because in India we are having three types of roads, sir. One is asphalt road, tar road, and cement road, as well as the clay roads. In India we are having those three, and I proposed an algorithm of enhanced ENET D7 algorithm. In that I proposed that algorithm, and I got an accuracy there also. And later I started working on the potholes, whether in the roads, different types of roads, there may be a possibility of potholes presented or not. So we need to verify that whether potholes are presented or not on the roads. So for that reason, I started working on this one.
Okay. So there is another question about what about weather conditions like fog or dealing with that? What is the current situation about those conditions for this work?
Actually, here we are working with when the rain is there.
When the rain
When the rain is there, the water is filled on the potholes, sir. Like this. At this point of view, we are working. Sir.
Is it whole or some normal one?
Normal water. Sir?
How it is recognized the system?
Actually, here pothole is presented or not. We just convey that message as here pothole is presented. That's it. Whether it may be like a pothole or a big hole, I didn't focus till now. So right now, I focus on if it is there, hole is there.
Some level 4 vehicles.
Sir. Yeah, here, sir.
Level 5 or level 0?
No. Actually, level 0 belongs to, we can get. No, sir. Level 5 is fully autonomous vehicles. Right now, it is working in trial run is going on, but the problem. Level 5, it is not there, sir. Not there. But level 4, it is there. In the year 2020, I kept already, no? Actually, what they are planning is, at the time, till now, they are keeping a one particular lane. In that lane only, those vehicles are running. So, but they tried in this 2023, they tried on real roads, real scenario. They are trying in that real scenario, normal vehicles are, self-driving vehicles are there, normal vehicles are there. At that situation, these accidents are happened, sir. When they are trailing, it was happened.
How you are going to find out the depth of the particle actually with this algorithm? Can you find out the depth of the particle?
No, sir. Till now, I didn't work on that. So whether I just.
This anonymous vehicle is going to find out how much range of or how much distance the particle will give?
It may be 50 meters max 50 meters. Because right now in India we are having only level 2, sir. This work is also not incorporated in level 2 vehicles. In the level 2 vehicles, the incorporation is only lane following vehicle is there, which you can find it in Mahindra XUV 700 as well as the Honda Elevate. There the lane markings are presented on the roads. In that roads, the vehicle will run when finding out the lane markings presented or not. When the lane marking is presented, by considering the lane marking, those two vehicles are running in level 2. Level 2 only, sir. Not level 3 is not at all launched in India. Level 3 need to incorporate some more points like the lane marking need to classify, because we are having different types of lane markings on roads, like continuous lane is there, dashed lane. In the dashed lanes, so different lane markings are there, and those working is not done till now, sir. In foreign countries are also, what they are doing is, they are focusing when the vehicle is moving, because they are focusing on lane, because there we have some constraints in lane driving, sir. So no one will change in lane, they will follow the lane markings, but India, we know that what was happened. So with that reason only, level 2 vehicles are already running, but level 3 is under press. So we need to incorporate this concept also in level 3. Thank you all, and next concept is also mine only, paper number 244. I don't want to waste dignitaries' time. I will continue with that next topic also.
A very good afternoon to dignitaries and all the students. And myself, P. Murali. So I am the research scholar from NIT Nagaland. And my research area is skin cancer detection using deep learning techniques, and under the guidance of Dilwar Hussain Majumdar sir. And now my paper ID is Ensemble Deep Learning Framework with Transfer Learning and Data Augmentation Classification Skin Cancer. So this is my objective 5. So I achieved the objective 5 using this paper. So this is the flow of my presentation, and now coming to introduction. So skin cancer is a globe. So literature survey, this is about literature survey. I collected from different papers from 2017 to 25, and this is the methodology. So it includes mainly the dataset collection. Here I used the dataset HAM 10,000. So where we have various datasets for determining the skin cancer like ISIC. This is the standard dataset. It is available on the internet, and HAM 10,000. It contains 10,015 images. In that 6,000 images are for the training, and remaining 4,015 images are for test set. And after that, so we have to class different types of skin cancers are available, like basal skull carcinoma. Like that, we have different categories of skin cancers are available. So in that, I have to divide all those categories of cancers images into 7 classes. So after that, I apply to data processing and augmentation. So in this data processing, so we have to apply the general operations with the images like resize and normalization, and the augmentation technique include the scaling and image rotation and cutout. So these are to apply to all the skin cancerous images in order to reduce the boundaries and clusters on the remaining, because one of the major challenge of the skin cancer images is we have to analyze the boundaries, and we have main challenge with the hair on the skin, and then we have to apply for the transfer learning. Here we used pre-trained CNNs, and the remaining 3 ensemble models like ResNet 152, DenseNet 201, and EfficientNet 117. Like that, we have to apply these types of algorithms on those images who are already completed operations with the scaling and rotation and cutout. So after that, I can apply to the ensemble model. So here I used these operations with these are the deep learning models. So number of all the images are passed to the number of layers, thousands of layers in the deep learning model. Each layer, each image will be rescaled and analyze the correct boundary and remove any noise present in the skin cancer image. So everything will be determined in this ensemble learning, and after that, prediction. So our aim is to predict whether the image is skin cancerous image or not. So in this prediction stage, it is observed that some of the I already tried with some of the non-cancerous images. So I got 96 point. So this is 96.2 is accuracy I achieved with my proposed model. So remaining accuracy and precision weighted or AUC ROC curve, these are the results of my paper. And these are the algorithms: ResNet, DenseNet, and EfficientNet B7, VCC 19. So all these are called as different types of ensemble algorithms. So I applied all those with the deep learning models to get this efficiency. And this is the result I got. So using accuracy, precision, recall, and AUC ROC curve. And coming to conclusion, so all the ensemble models are outperforms the deep learning models, because once we apply any models on the machine learning models, so the deep learning models perform well because it observes the layers, skin cancers images, and whatever the images it is observed from the depth to the layers outside the models, and then it is applied to the different ensemble models to get the required accuracy. And then I achieved in this paper 96.2, and ensemble learners, we have CNN models are there. Those are standard for the image processing techniques. So even though I use different deep learning models like ResNet, DenseNet, so though I achieved rather than the CNN, and provides reliable and interpredictable predictions for clinical support. And these are my references. Thank you. Any questions? Final outcome. Yes, sir. Actually, for each. Okay, sir. Actually, we are using efficient net algorithm. So out of those remaining dense net and dense net algorithm and VGG 19, I got the best efficiency for the efficient net algorithm. It gives only the 96.2 accuracy. So I achieved remaining algorithms. I got less than 80 or less than 96. So best one I got for the efficient net algorithm. So I consider that one only in that ensemble model.
Go to slide number 7. Yes. No, I think next one, next slide. Maybe one more slide. 6. Slide 6. Or somewhere it is missing. Somewhere one slide before to it. No, in result section. I just want to. Yeah, here, just talk here. 9, I think. Yeah, macro F1 and weighted F1. How
Yes,
do you
sir.
differentiate these two?
Actually, in the accuracy itself, for the images, especially we got this micro F1 and weighted F1, sir. In deep learning models, the image is passed to the various layers. In each layer, we have to calculate the pixels based on their weights. So each layer in the deep learning model, we have to calculate some weights and their covariance and noise of the vectors. So that's why we got weights for the F1, and macro means we have to find out the minimal things about the skin cancer image. Actually, I achieved these performance metrics. Okay. Actually, HAM 10,000 dataset contains the real clinical images, sir. So with that images, I got the statistical methods. No, sir. For my no, sir. No, sir. Yes, for this I only use this one only. Okay. Thank you, sir. Thank you so much, everyone.
Thank you, sir. Now, I would like to invite paper ID 337, titled Prediction.
Good evening, sir. I am M. Venugopal Rao, PG student from GG University, Rajavendravara. Today I am presenting paper 337, that is prediction of compressive strength of SCM blended sustainable concrete using a multi-layer perception model. The forward.
Yes.
These are my outline on the our work. Abstract introduction, data set, parameters, methodology, result and discussion, observation, conclusion, references. Abstract. Speaking how strong concrete will be when it includes extra ingredients is not straightforward. Things like slag or fly ash change behavior in ways hard to pin down. Old math rules often fall short because they cannot capture the targeted way of components behave over time. A different route taken here uses a machine learning model known as MLP, shaped by experience rather than fixed equations. Is it? Okay. అంటే ఇది బ్యాక్గ్రౌండ్ అండి అంటే మై అదే దీంట్లో హియర్ we have taken
What he said is
knowledge
like,
comes from 1030 actual mixes gathered from earlier research studies.
in your own words, with one or two lines, you talk about your problem and then directly go to your methodology and then result section.
Ordinary mixes, physical finding strength, compressive strength takes a lot of time. Using this MLP model, variety of mixes, compressive strength of due to various
ML
blending with supplementary.
Multi-layer perceptron?
Huh?
You are talking about multi-layer perceptron? MLP? Multi-layer perceptron? Okay.
Supplementary cementation metal, when they are added to the IS codes are not limited, they cannot explain anything. So this concept is taken.
Right, sir.
Background and problem of statement, growing demand of eco-friendly construction materials, partial replacement of cement with fly ash and blast furnace slag, reduced CO2 emissions and improved durability. Strength behavior becomes unpredictable with SCM addition. Slow pozzolanic reactions complicate hardening process. Water content significantly influences strength development. Need for data-driven approach. Increasing complexity reduces reliability of conventional models. Artificial intelligence captures hidden non-linear relationships. Neural networks adapt to unpredictable material behavior. Multi-layer perceptron suitable for complex regression tasks. Many 1030 diverse concrete mix designs collected from previous literature. Custom MLP developed to predict compressive strength. Focus on stability and reliability across various SCM blends. Concrete mix designs collected from published research. Includes wide variation in ingredient proportions, covers different curing durations, contains mixes with varying fly ash replacement levels, contains mixes with varying slag replacement levels, designed to ensure diversity for reliable modeling. Input and output, input parameters, cement content, slag content, fly ash content, water content, superplastase dosage, coarse aggregate quantity, fine aggregate quantity, curing age. Output is compressive strength. Methodology. Single data set used throughout the study. Uniform pre-processing applied to all data. Identical rules ensured fairness in modeling. Results depend on model design. Reproducibility maintained using fixed procedures. Controlled experimental setup improved reliability. Natural ingredient strength relationship preserved. Data pre-processing. 80% data used for training, 20% reserved for testing. Fixed random seed ensured reproducibility. training data used to learn patterns, test data evaluate to real generalization ability. MLP model architecture. MLP regressor selected for nonlinear strength prediction. 2 hidden layers of 64 neurons each used. Or ReLU activation used for faster learning. Handless complex supplementary cementation material ingredient interactions. Trained up to 2000 interactions. Back proportion used up to weights. This is the MLP structure. The input layer is cement, fly ash, slag, water, superplastizer, coarse aggregate, fine aggregate, curing agent. Output layer is compressor strength. 2 hidden layers are in layer 1 and 2 and interacted faster interaction with ReLU activation is used. Results and discussion. Performance metrics. MLP evaluated using standard regression metrics captured complex nonlinear material strength relationships. Training R square is equal to 0.94, 94% variation explained. Testing R square is equal to 0.88, strong generalization. Minimal drop between training and test phases. Training MAE is equal to less than 3 MPa. Test MAE is slightly above 4 MPa. RMSE remained within the acceptable limits. Performance matrices. R square for training is 0.9443. R square for testing is 0.8771. RMSE for training 3.977 MPa. RMSE for testing 5.6276 MPa. MAE for training 2.9955. MAE for testing 4.0170. Finally, MAPE for training is 10.35% and MAPE for testing 11.91%. Based on this, the small difference between training and testing metrics indicates good generalization with minimal overfitting. Discussion. MLP effectively captures complex nonlinear relationships. Strength depends on cement hydration and pozzolanic reactions. Fly ash, slag, water content, aggregates and curing age interact. Layered neural structure lends hidden material connections. Model lends directly from raw experimental data. Features scaling ensured balanced learning across inputs. Controlled training cycles prevented instability or overfitting. Stable results observed in both training and test data. Model generalizes well to new eco-concrete mixes. Neural networks provide suitable for sustainable concrete prediction. MLP performance. Conclusion. MLP tested on 1030 SCM concrete mixes. Strong performance in both training and testing. Nearly identical scores across data splits. Indicates true learning. Residuals evenly distributed without bias. No visible overfitting behavior. Captures nonlinear SCM material interactions. Stable and consistent prediction capability. Practical implications and final insight. Neural networks outperform traditional linear equations. Handles complex cement, slag, fly ash interactions. Proper scaling and architecture ensured stable training. Reliable strength estimates for eco-friendly concrete. Useful during mixed design and optimization stages. Faster alternative to repeated laboratory trials. More dependable than single linear or bagging models. Strong potential for sustainable construction planning. These are the references, sir.
Thank you, sir. Now I would like to invite
Good evening, everyone. Myself, D. Amrit Kiran, pursuing MTech degree from Godavari Global University, and here is my project title, Data-Driven Prediction of Compressive Strength of SCM Blended Sustainable Concrete Using Decision Tree Regression. Here, we are going to derive that in civil construction, there are many parts that are implemented so far, so that the construction cost is effectable, and also the stage of construction and the cementitious materials that we are using in the now at all. So it's very encourages to have that materials such as fly ash and slag furnace. So these are we are using currently now in the construction. So depending upon the eco-friendly construction, we are going to have a decision tree regression model through AI, artificial intelligence. So we tested nearly 1030 concrete mix designs that are available for us from the Google internet. So we made artificial intelligence to train 80%, and we already have 20% for the testing purpose, and we just give inputs like cement, slag, fly ash, water, and super plasticizer, and the aggregates that are coarse and fine aggregate quantities to the algorithms, and we tested like this model. So we can see that decision tree regression model, it works like this. So this was used just for training, and the output was compressive strength basing on megapascals. This decision tree regression is used for just prediction of the different proportions of the materials. Like we have so many tests that are concluding that compressive strength based upon the mix proportions. But if we mix up with other proportions, it can't be as accurate as it. So we are going for decision tree model so that we can give number of proportions like fly ash, furnace, and etc., so that we can get the compressive strength accurately. So this R square measures the goodness of fit, and means coefficient of the determination, means root mean square error penalizes large prediction errors, and mean absolute error shows average error in megapascals, and measurement mean absolute percentage error indicates percentage of the deviation. So from the training, R square value that performance is 0.95% from the training, and RMSE value is 3.42 megapixels, mega absolute error MAE value is 2.33, mega MAPE value is 8.19%. So these are the testing values. From this training, we tested from the validated results 20% we are having, and the testing results was R square value was 0.8%, and RMSE was increased, and MAE also increased, and MAPE is also increased from these overall values. So with this decision tree regression model, we can just have a superfit, and it was implemented to test the proportions in various cementitious materials furtherly to eco-friendly generations. It was excellent performance on training data and clearly evidence of overfitting. Model clings to learn training specific rules. It was more effective when used in an ensembles methods that was from the training to the testing data. That's it. Thank you.
Yeah, what's your name? Kumar? Which Kumar?
Dhaim Amrit Kiran, sir. Amrit Kiran.
Kiran.
Yeah.
Okay. So just before to you, there was another person's presentation, right?
Yes, sir. Yes, sir.
So other than methodology, what are the differences to you both?
That was
Are both of you are colleagues?
from the same college, sir.
Same college?
Yes.
Working on the same data?
Yes, sir.
Only ML method that you are using is different.
Yes, sir.
MLP and you are using decision tree.
Yes, sir. Regression, sir. Regression means it's if we given some materials that were not existence to the algorithm, it can be determined by the value. Maximum to 0.8%, sir. Yes, sir. Yes, sir. Yeah.
So other see, there are a lot of features the other guy has taken, right? Other
Yes, sir.
person. And what about you? You are using same?
No, sir. Decision tree was a different model and MLP
No,
was a
not
different.
model I am talking. The features which you have considered and he has considered.
Features, we considered that the same 1030 proportions, sir. Thank you.
Thank you, sir. Now I would like to
So my topic is multi-scale. Good evening to one and all. My name is Sasikala. So, paper ID is 175. My topic is multi-scale convolutional neural network attention mechanism to enhance melanoma detection in the anomoscopic images. So in this, so nowadays, the cancer is very fastly it is affecting, especially the skin cancer. The symptoms are very mild, and the recognition of early detection is very much vital. Classification, sir. During the literature survey, so these are the earlier. So the architecture for CNN, so that is used here, the general one, convolution layer and pooling layer and fully connected layer and the output. So that we are following. So for classifying the lesions So these are the literature survey that we follow. So early, we use the CNN algorithms to find the detection of skin cancer. Later, we go for different data set we are using. So in that also we have some limitations. So those are limited interpretability and required high computational resources. A recent one, sir, yes, sir. So 2025 skin lesion data set. So this is the latest one, sir. And dermoscopic images, so that is my work, sir. Here, it increasing the training time. So that is the limitation, sir. So regarding the literature review. Okay, sir. So these are the methodologies we are using. So we have different challenges, data set and pre-processing. So it depends on the data set that we are using. Several criteria it will affect, like age, previous literature survey, we have different type of data set. So these are the techniques that we follow, especially in the methodology. So this is my proposed work, sir. So in this, we use the convolutional layer of different operations. We set for different filters, and we have different outputs. So training and classification. So we do, so these are the results, sir. So experimental results, we need to split the data set like training. So this, yes, sir. It depends on the type of data set, sir, that we are taking. Yes, sir. The combination of data set will influence, yes, that we do using the accuracy matrices, we can overcome, sir. The data set is a challenging thing, sir, that we select. It might be, depends on the geographic issues also, sir. Thank you, sir.
Guest, Dr. Suresh Dara, sir, Professor in the Department of Computer Science. Professor in the Department of Computer Science and Engineering, to kindly come forward and accept our token of appreciation.
Yes, some suggestions and remarks for this session. So we have seen two papers are a little similar, just only methodology they have, changed when they executed that data set. But practically, we expect even more. It's not just not only changing the methodology, just instead of decision tree, MLP, and instead of MLP, decision tree. You could have compared, since you are co-scholars, my suggestion is, since you are working together in the same college, you could have compared among you. So that was my suggestion. And coming to the other works, since this is a conference, it works here, but usually the results, we expect even more. That's my observation for the rest of the papers. And all the papers are accepted as per the conference guidelines. And maybe in future, if any one of you, from the student side, if you're working, and the result should be extensive, not limited. Make yourself, results should not be comparing with only one or two or restricting yourself. You should be very extensive. Then acceptance and the weightage for your paper will be high. Got it, what I am trying to say? And yeah, so any other session chairs want to give any thoughts? Yeah, morning session, I missed to give my contact details, and someone can take by scanning the QR code over here. You just scan here and you can connect to me. My PPT
క్లోజ్ చేసేదా
క్లోజ్ చేస్తారు భలే వీళ్ళ గ్రూప్లో పెట్టారు నేను అందుకని ఉంచమన్నారు అది.
Dr. P. Subbarao, sir, to join for certificate distribution.
I invite paper ID 168 to come and receive the certification. Ms. Pramila Rani, ma'am. Paper ID 188, Sarat Kumar, sir. D. Nagavenkata Sindhu, sir. N. Sri Prakash, sir. Pampana Murali, sir. Amrut Kiran, sir. Amrut Kiran, sir. Mutyala Venugopal Rao, sir. Sasikala, ma'am. As a mark of our gratitude, I request our honored guest, Dr. Suresh Dara, sir, Professor in the Department of Computer Science and Engineering, to kindly come forward and accept our token of appreciation. I also request Dr. T. Sudharani, ma'am, Head of the Department, Computer Science and Engineering, and Dr. P. Subbarao, sir, Publication Chair, to present the memento to our chief guest. With this, we come to the end of today's paper presentation session. On behalf of the Department of Computer Science and Engineering, I sincerely thank our respected external session chairs, Dr. A. Chandrasekhar Rao, sir, Dr. D. Suresh, sir, and internal session chair, Dr. V. Ravikishore, sir, and all the presenters for their valuable time and contributions. Your research insights and discussions have truly enriched this session. Thank you everyone for your participation and attention. Have a wonderful day ahead. Education.